Hello, welcome to our Sustainable Sourcing Checklist Generator demonstration. My name is Nat Springer. I'm a postdoc with the Agricultural Sustainability Institute working on our Sustainable Sourcing project. For a summary and development of this project to date, check out our other webinars and presentations also posted on our Institute's website, which can be seen at the bottom of the screen here. But quickly, the main purpose of this project is to help food companies and other food system stakeholders develop frameworks that can define and measure the sustainability of agricultural raw material sourcing. These frameworks can then be used to develop strategies to improve sourcing practices across commodities and regions. This demo presents a specific process that our team has developed to achieve this purpose. This process can be used by anyone who wishes to create a comprehensive list of sustainability issues and indicators to measure the sustainability of their agricultural raw material sourcing for a specific supply chain. In other words, this process takes the general concepts and tools that our team has developed to this point and shows how to apply them for a specific commodity sourced from a specific place. Now, just to give this a bit of general context, our team has harvested a large data set of over 2,000 existing sustainability indicators from a number of existing global initiatives and data sets relevant to the sustainable sourcing of agricultural raw materials. These indicators provide information about different types of issues, including natural, human, social, political, physical, and financial issues, and many indicators are relevant to multiple categories. Although the multitude of indicators gives decision makers many ways to measure sustainability, it also makes it difficult to identify a manageable set of indicators to represent the issues one cares about in a specific context, since it is unrealistic and unnecessary to track the entire set of indicators in each case. At the same time, it would be nice to know that any issues and indicators chosen are recognizable and being used by the broader sustainability community, and also ideally by groups working on a similar list of issues, commodities, and regions. So the goal then becomes how to identify this subset of indicators for a given case, drawing from this larger global set of existing and consistent issues and indicators. So the main goal of this demo is to show how a company may derive different sets of indicators to measure different issue lists for a specific commodity, region, and sustainability framework. And this is the checklist generator process shown here. Now, as you can see in this slide, we've listed 4 cases that identify comparable issue and indicator sets. All legitimate sets, but they'll be different depending on these 4 contexts and parameters set by the user. The main takeaway here is that different indicator sets will be useful for different cases, and that the goal is not to identify an optimal set, but a useful, manageable one that is informed by a pool of available indicators and issues that come out of a scientifically validated and consistent organizational process. To illustrate the role that sustainability frameworks can play in this process, for instance, note that the first 2 cases here are consider the impacts of sourcing decisions on sustainability issues, while the latter 2 consider the vulnerability of supply chains to the issues. Now, in this demo, we'll look at the first example, impact case 1. If you're interested in seeing a comparison of all 4 cases, simply see the longer version of this demo, which will also be available on the ASI website. So for this case, the first step is to choose relevant issues that are impacted by sustainable sourcing from a broader list of global issues. As described in our previous presentations, our team has harvested this global list of 44 sustainability issues from the broader sustainability community. Each issue is integrated from these sources using a controlled vocabulary, and these integrated issues are hence comprised of various component issues that cut across these 44 integrated ones. For example, the integrated issue water includes water availability, water scarcity, water pollution, etc., which are all components of the integrated issue water. Now, this network of issues then provides a pool from which to draw a subset of issues relevant for a specific context. Again, our team has collected a concurrent list of over 2,000 indicators that provide information about these 44 integrated issues and their components, and this is shown in the funnel at the bottom right of the screen here. So keep an eye on this funnel as we proceed through this process, and you'll notice how the number of indicators becomes more manageable with each step. So our team here at UC Davis determined the issues that are impacted by sustainable sourcing of agricultural raw materials by asking the following question for each issue. Does raw material sourcing have a significant and direct impact on this issue? So if this question was generically true for any given issue, meaning in the context of the entire global food system, our team placed it in the impact framework. Now the picture here on the left is our UC Davis team. However, this question could be answered in any number of ways, including through participation with relevant experts and stakeholder groups. So the picture on the right is from a meeting our team had with a group of stakeholders back in December of 2012, where we presented this list of 44 integrated issues for comment and validation. So if we went through this process in a similar way with this group, you can see how this process could be thought of as a negotiation support tool, or a way of identifying the set of issues that are directly relevant for a given case, however narrowly or broadly defined. So again, at this generic entire food system level, this is the list of impact issues identified by our team. So you can see that this already slightly lowers our available indicators to measure these issues, as those indicators that only provide information about the gray issues drop out here. But ultimately, most users will not be interested in a generic global list, but a specific list of issues relevant to their regions and commodities. So we turn to impact case 1, which narrows the impact question to say, what is an appropriate indicator list for a comprehensive sustainability claim on the impacts of a specific commodity source from a specific place? In other words, what list should we use for this commodity from this place? Again, just as with the generic question, this more specific question can be answered with any number of participants present, ideally with a set of stakeholders who can best speak to the relevance of the issues from many different perspectives. So for the demo, our team has chosen to look at groundnut sourcing in northern Nigeria. So this was a commodity and region we chose to look at early on in this project in collaboration with our colleagues from Mars Incorporated. So say as a decision maker you're concerned specifically with the sustainability impacts of groundnut sourcing decisions in northern Nigeria. So which issues then become relevant in this case? And as an exercise to show how this would work, two of our team members, myself and the ASI director, Tom Tomich, considered this specific question for all 24 impact issues along with their various components. Ultimately, this process of identifying a subset of relevant issues for a given commodity and region can be done in collaboration with any number of stakeholders and experts, as mentioned earlier. So, but for this case, and for the sustainability impacts of groundnut sourcing in northern Nigeria, Tom and I identified 15 of the 24 impact issues as directly and significantly relevant. So note that these 15 issues still cut across all the different groups of natural, social, political, human, physical, and financial. So with these 15 issues identified, you can see that it has cut down our possible indicator set by 25%, or down to about 1,500 indicators. But this is still too many to be manageable. So how do we get to a manageable set from here? Now, one intuitive strategy would be to simply look through the list of nearly 1,500 indicators and begin choosing them one by one to represent each issue. Yet not only would this be a time-consuming process, but since many of the indicators can provide information on multiple issues, it's also likely that this one-to-one searching technique would result in an indicator set that is larger than necessary. So for example, consider this simple case with 8 issues and 5 indicators to measure them. There are many overlapping links, and hence not all indicators are necessary to represent all these 8 issues. So we could simply choose the first 3 indicators on the list, and they represent all the issues. But you can see that indicators 3 and 4 both link to issue 4. Both link to issue 4. Instead, we could choose indicators 2 and 5, which also provide information on all the issues, but only require us to track 2 indicators. So this set of 2 indicators also happens to be the minimum set of indicators that can represent these 8 issues. But again, you can see how the selection process becomes more difficult as the number of issues and indicators rises. In this case, nearly 1,500 indicators providing information on 15 integrated issues and their various components. So to assist us in this selection process for our large set of indicators and issues, our team has developed a tool that identifies the smallest set of indicators required to provide information about a given set of issues. This tool uses an algorithm that solves the well-known mathematical problem called the minimum covering set problem. So see our webinar on this tool for more detailed information about how it works. but it allows us to answer the question, what is the minimum set of indicators that can tell us something useful about the impact issues for groundnut sourcing in northern Nigeria? So the version of the tool we use for this demo is the integer programming algorithm. A screenshot of the program we used is showed here, which has the advantage of being very fast. It takes only about 5 seconds to find the minimum indicator set. So if we run this tool for a network of our network of 1,489 indicators linked to 15 impact issues for groundnuts in northern Nigeria, we find that the algorithm identifies 10 indicators that can be used to represent all 15 integrated issues and their components. So right away, this example shows the power of this tool, which is able to reduce the number of indicators by an order of magnitude. And for users who have limited time and resources, this indicator set has quickly become very manageable. So just as in the example, you can see that the lines here show which issues each indicator provides information about, again, spanning all capital groups. And of course, there's links to multiple links of indicators to the integrated issues show that there are indeed many component issues that must be represented underneath each one of these integrated issues. Still, even though this tool has successfully identified this initial manageable set, it does not mean that this minimum set of indicators is the list that we should use in this case. Instead, this tool has gotten us to another step in our process where we can ask a more refined question to get at this manageable list. And now we refine our question for this impact case 1 just a bit more to ask, now what list of indicators should we use for groundnut sourcing in northern Nigeria? So as if we consider this question for each indicator in our minimum covering set, we may find that some of these indicators, although chosen by the tool, just don't make sense for this case. For instance, maybe a chosen indicator makes sense in Southeast Asia but not for Africa. Or maybe it's measured at the countrywide scale and has no available or affordable data at the local scale. Or maybe an indicator just isn't a good fit for the framework or issue for any specific context. So if we now come back to our initial minimum set and ask this question of each indicator, we can exclude indicators from the set that we don't want to use. For instance, extreme weather events and population growth may be better vulnerability metrics than impact metrics, and turnover profit may not be the best indicator to consider the impacts on global supply chain markets. So once we exclude these indicators from the pool of the ultimate larger pool of indicators, we can use our tool once again to choose an updated set. So we run our tool, and within seconds, we have a new list. So still 10 indicators. The ones in bold are the same from the first run. So this tool chooses 5 new indicators to keep the indicator set as small as possible. And you can see here, again, the links showing that each impact issue is indeed covered. And it is indeed covered. Still, but again, some of these new indicators might not make sense either. For instance, extreme climate events is a very similar vulnerability indicator to extreme weather events. So if we run it again with these exclusions, we can run our tool one more time. And within 5 seconds, we have another list. Now this time it's 11 indicators. So by knocking indicators out of contention, our algorithm can no longer find 10 indicators to represent all 15 issues, but instead needs 11 to get the necessary representation. But at this point, after only 3 rounds, our team at UC Davis here looked at this list and was already satisfied with the chosen indicators to represent the impacts of groundnut sourcing in northern Nigeria. Of course, with more stakeholder and expert knowledge in the room, this process might continue for some time, and it very well could. The indicator list possibly getting slightly larger as more runs are needed. Yet the order of magnitude of this list would remain similar, and the discussions and negotiations would begin to facilitate convergence upon a useful, transparent, and salient list. Furthermore, since these indicators and issues are semantically consistent, meaning they use consistent terminology and are derived from well-known and accessible scientific sources, such a list can be communicated across stakeholder boundaries with ease. So revisiting our initial diagram of the checklist generator process, we've gone from a large database of indicators representing the global set of sustainability issues to a manageable set of only 11 indicators that provide information about the impacts of sustainable sourcing of groundnuts in northern Nigeria. So at this point, I should highlight once again that this is a specific set for a specific case. Other commodities in other regions will have different sets. So if this process is followed for multiple commodities in multiple regions, we may begin to see similarities between the chosen lists. In other words, we may see specific indicators come up again and again, helping other users find indicators that are commonly used and ultimately moving closer to identifying globally applicable sustainability metrics from these individual cases. Now, since our sustainable sourcing project promotes an open data philosophy with information about issues, indicators, frameworks, sources, and ultimately data sets, alongside the linkages between these information components that are available to everyone, and since the project uses controlled vocabulary to synthesize issue definitions from other perspectives, which simultaneously link to our information available using other semantically enabled information and data sets, users who go through this process have the potential to share their issue and indicator list with the global community and make their issue indicator choices transparent and comparable. So our team has currently developed a semantically enabled wiki platform where this information can ultimately be shared and updated. So please stay tuned for an upcoming webinar on our informatics strategy and on how the semantic web of information and the sustainable wiki will ultimately contribute to a global definition of sustainability for agricultural sustainable sourcing. So developing such use cases is the current focus of this project. In doing so, we are also exploring additional ways to format our tool to help users come up with the best list for a given case. For instance, instead of excluding indicators, the user may want to include specific indicators they know well, or a group, in fact, may decide that representing 80% of all the relevant issues is a satisfactory place to start. And for those users who recognize the importance of both sustainability impacts and vulnerabilities, can come up with unique lists to measure each framework. So for more detail on these considerations, please see the longer version of the same webinar, which is also available, again, on the ASI Sustainable Sourcing website. So our team is currently developing partnerships to use the Sustainable Checklist Generator approach to explore specific commodities and regions. If you're interested in becoming a partner or have a use case that we could consider, please let us know. We are excited to begin generating these checklists. So thanks for listening, and stay tuned.